Hello students, let's do playing with numbers exercise 3.7. So we are doing exercise 3.7 and we are with question 6. The traffic lights at three different road crossings change after every 48 seconds, 72 seconds and 108 seconds respectively. Okay, let's understand this first part of the question. So we're talking about traffic lights at three different road crossings. They're not on the same road, three different road crossings, and they change after every 48 seconds. Now the first traffic light changes after every 48 seconds. That means if it is a red light, after 48 seconds, it will turn into the next color and then it will turn into green. Okay, so it keeps changing that way after every 48 seconds. Now, at another road crossing, the traffic lights change after 72 seconds. And at the third road crossing, it will change after every 108 seconds. So this is how the traffic lights at three different crossings change. Now here they're saying if they change simultaneously at 7 a.m. Simultaneously means at the same time on three different road crossings, but they're all changing at 7 a.m. So the first one will change at 48 seconds at 7 a.m. Second one will change at 7 a.m. and the third one also will change at 7 a.m. So if they change at the same time at 7 a.m., at what time will they change simultaneously again? So next, at what time will they change? That means the shortest time possible, isn't it? After say 7 a.m., the next change will be the shortest time possible. That means we are talking about the lowest or the least common multiple, that is LCM. So in this case, we have to find the LCM. So time at which the lights will change simultaneously again will be the LCM of 48, 72 and 108. So let's find the LCM of these three numbers. Let's begin. So we have 48, 72 and 108. These are all even numbers. That means we can divide all these by 2. 2 2s are 4, 2 4s are 8. 2 into 24 is 48. Next we have 72. Let's divide 72 by 2. 2 3s are 6 and there is 1 left, so that becomes 12. So 2 6s are 12. Then let's go to the next one, 108. Let's take 10. 2 5s are 10 and 2 4s are 8. Again, they're all even numbers. We can divide by 2. 2 1s are 2, 2 2s are 4. Then we have 36. 2 1s are 2, 3, there's 1 left. So that's 16. 2 8s are 16. And then we have 54. 2 2s are 4. There's 1 left. So that's 14. 2 7s are 14. So now we can continue. We still have two even numbers. We can continue with 2. 2 6s are 12. 2 9s are 18. 27 we cannot divide, so we bring it down. Again we can do with 2 because there's one even number. 2 3s are 6. Bring down 9 and bring down 27. Now we can use 3. 3 1s are 3. 3 3s are 9. 3 9s are 27. We can continue with 3. So bring down 1. 3 1s are 3. 3 3s are 9. Again we can use 3. So this is 1, 1 and 3. 1s are 3. So we finished dividing. Now let's find the LCM. Now how many 2's do we have? 1, 2, 3, 4. So let's write that down. 1, 2, 3 and 4 2's. Now we have some 3's also. How many? 1, 2, 3. We have 3 3's. So let's multiply 3 into 3 into 3. So now let's multiply these numbers. 2 2's are 4, 4 2's are 8, 8 2's are 16. So when we multiply the 2's, we got 16 into 3 3's are 9, 9 3's are 27. So what did we do? We grouped all the 2's together and we got 16. We grouped all the 3's together and we got 27. Now we can multiply these two, 16 into 27. So let's multiply 16 into 27. 7 6s are 42, carry 4. 7 1s are 7 plus 4 is 11. Second step, 2 6 are 12, carry 1. 2 1s are 2 plus 1 is 3. So now let's add this up. 2, 1 plus 2 is 3. 3 plus 1 is 4, 432. So the LCM is 432. And what is the LCM we said? We said the LCM is the time at which the lights will change simultaneously again. So 432 will be seconds because these are all in seconds. So 432 seconds. Okay, so this is the time. Now, the time that will take for them to change simultaneously. Now we have to put it in the form of time like this. That means what time will it be? If we have it in seconds, let's convert it to minutes and seconds. Now to convert this to minutes and seconds, how do we do it? We say in 1 minute we have 60 seconds, isn't it? So to find out how many minutes there are in 432 seconds, we have to divide 432 by 60. We have to divide this and we'll know how many minutes there are in this. So let's do that division. 432 divided by 60. Now 6 sevens are 42 we know. So 60 into 7 will be 420 minus 2. 3 minus 2 is 1. So we can write this as 7 minutes and 12 seconds. So what is the question? The question is, at what time will they change simultaneously again? That means after 7 minutes and 12 seconds. First they changed at 7 a.m. After 7 a.m., 7 minutes and 12 seconds, all three traffic lights at the different road crossings will change. Okay, so I hope you understood. It's first changing at 7 a.m. and next it will change 7 minutes 12 seconds after 7 a.m. So let's write that. The lights will change together after every 432 seconds. That means simultaneously at 7 minutes and 12 seconds. So this is after 7 a.m. They will change at 7 minutes and 12 seconds. Question 7. Three tankers contain 403 liters, 434 liters and 465 liters of diesel respectively. That means the first tanker will contain 403 liters, second tanker 434 liters and the third tanker 465 liters of diesel. Now what are we asked to find? We have to find the maximum capacity of a container, one container that can measure the diesel of the three containers the exact number of time. So think of one container, okay, that can have the maximum capacity of diesel. That means from all these tankers that have these different amounts of diesel in it, now we have to put it into one container so that we can get the same amount, maximum amount, and how many containers can be filled like that. Okay, so think of a container can hold the maximum capacity of diesel when we measure from all these and put it into this container. So let's begin. So when we are talking about maximum, remember we're talking about H.C.F. So maximum capacity of tanker means we are talking about the H.C.F. So let's find the H.C.F of these three numbers. So first let's find the H.C.F of 403 by the prime factor method. So now if you look at 403, this is divisible only by 13, which is a prime number. 13 into what will give us 403. So let's divide 403 by 13 and see. 13 threes are 39 minus, now if you borrow from here, this becomes 10. 10 minus 9 is 1 and then 3, 13 ones are 13 minus 0. So 13 into 31 times. Now how did we decide that we should use 13? Think of all the prime numbers that you have. Okay, from the beginning, think of a few prime numbers that you have. So if you think of the prime numbers, you have 2, 3, 5, 7, 11, 13 and so on. So when you see it is not divisible by 2, it's not divisible by 3, it's not divisible by 5, it's not divisible by 7 or 11. That's how we've come to 13. That's how we used 13 here. So now we can see 13 into 31 is 403. That means we have to divide 31 again. Now is 31 divisible by any of these prime numbers? It's not divisible because 31 itself is a prime number. So we're going to divide 31 by 31 itself. So this becomes 31. 31 ones are 31. So we finish finding the prime factors of 403. So let's write that here. 403, the prime factors are 13 into 31. Now let's find the prime factors of 434. So 434. Now 434 is an even number, so we can divide this by 2. 2 twos are 4. Now let's take 3. 2 ones are 2, so there's 1 left. So that becomes 14. 2 sevens are 14. Now look at this number 217 and think of the prime numbers. Now we have 2, 3, 5, 7, 11 and so on. These are all the prime numbers. Now is it divisible by 2? 217 is not divisible. Is it divisible by 3? 21, 3 sevens are 21, but this number 7 is not divisible by 3. Is it divisible by 5? It's not divisible by 2, 3, 5. Is it divisible by 7? Yes, we can divide it by 7 because 7 threes are 21 and 7 ones are 7. So again, you can see we've got 31, which is a prime number. So we'll divide it by 31 itself. 31 ones are 31. So now we can write out the prime factors of 434. What are they? 2 into 7 into 31. Now let's go to the next one. That is prime factors of 465. So since it's ending in 5, we can use 5. Now let's take 46. 5 nines are 45, but there's 1 left, so that becomes 15. 5 threes are 15. Now 93 is divisible by 3. 3 is a prime number. 3 threes are 9, 3 ones are 3. Again, we've got 31, which is a prime number. So divide 31 by 31 itself. That's 1. So now let's write all the prime factors of 465. Prime factors are 3 into 5 into 31. Now to find H.C.F, remember we look at all the factors here and we circle the ones that are common. What is common to all three? Now we have 13 here but no 13 here. We have 31 here, 31 here and 31 here also. That means 31 is common. There's nothing else that's common. So let's circle 31. So we have circled 31 and that's the only number. That means the HCF of 403, 434 and 465 is 31. And what did we say is the HCF? It's the maximum capacity of the tanker. Okay, so let's write that down. The maximum capacity of a container that can measure the diesel of the 3 containers, the exact number of times is 31. That means that, so this is 31 liters. That means to fill a container which has 31 liters, from this container we take it 13 times, from this container we take it 2 into 7, 14 times, and from this container we take it 3 into 5, 15 times. So the maximum capacity of the container is 31 liters. Question 8. Find the least number which when divided by 6, 15 and 18 leaves a remainder 5 in each case. That means first we are talking about least number. That means we have to find the LCM of these 3 numbers. So first let's do that and then we'll think of this part. Okay, so let's find the LCM because that will give us the least number. So let's begin. 6, 15 and 18. 6, 15 and 18. All 3 numbers are divisible by 3, isn't it? So 3 2s are 6, 3 5s are 15, 3 6s are 18. Again, let's use 3. 2 is not divisible. I bring it down. 5 is not divisible. Now we have 6. 3 2s are 6. Now I can use 2. So 2 1s are 2. I bring down 5. I say 2 1s are 2. Now I have 5. 1, 5 ones are 5 and 1. Now I can find the LCM. So LCM is equal to 2 into 3 into 3 into 5. So let's multiply and get this. 2 3s are 6, 6 3s are 18, 18 into 5 is 90. Now the LCM is 90. Now the question here is, find the least number which when divided by these three leaves the remainder 5. Now if you take 90 and divide it by 6, it will divide it completely. Your remainder is going to be 0. If you divide this by 15, again your remainder is going to be 0. Divide this by 18, the remainder is going to be 0. But here they're saying it should leave the remainder 5. So 90 is what you have got. If it should leave a remainder 5, then what should we do? Take 90 and add 5 to it. Now your number is 95. If you divide 95 by 6, your remainder is going to be 5 because 90 is completely divisible. What is left is only 5. If you divide it by 15, again your remainder is 5. If you divide it by 18, again your remainder is 5. So if you take the number 95, then that will leave a remainder 5 when it is divided by each of these. So what is our answer here? Our answer here is the least number is 95. Let's write that down. The least number which when divided by 6, 15 and 18 leaves a remainder 5 in each case is 95. So this is our answer, 95. Question 9. Find the smallest 4-digit number which is divisible by 18, 24 and 32. Smallest means let's find the LCM. Now first let's find the LCM and see whether it's a 4-digit number. So let's begin. LCM of 18, 24 and 32. Let's find 18, 24 and 32. Okay, now they're all even numbers, so we can use 2 here. 2 9s are 18, 2 into 12 is 24. Now 32, let's divide. 2 1s are 2, there is 1 remaining, so that becomes 12. 2 6s are 12. So here we have 16. 2 into 16 is 32. Again we have even numbers, so we can continue with 2. 9 is not divisible, we bring it down. 2 6s are 12, 2 8s are 16. We still have some even numbers. So divide by 2, bring down 9. 2 3s are 6, 2 4s are 8. We still have an even number. Let's continue. Bring down 9, 3, 2 2s are 4. Again we have an even number. So divide by 2, 9, 3, 2 1s are 2. So now let's continue with 3. So that will be 3. 3s are 9. 3 1s are 3. Bring down this 1. We can continue with 3 again. 3, 1, 1 and 1. Okay, now let's find the LCM. LCM of 18, 24 and 32. Let's count the number of 2's. 1, 2, 3, 4, 5. There are 5 2's. So let's write that down. 1, 2, 3, 4 and 5. Now how many 3's are there? 1, 2. 2 3's. So into 3 into 3. Now let's multiply. 2 2's are 4, 4 2's are 8, 8 2's are 16, 16 2's are 32. 32 into 3 3's are 9. So I grouped all the 2's and got 32. Then I grouped the 3's and I got 9. This is to make our multiplication easier. So 32 into 9. 9 2's are 18, carry 1. 9 3's are 27 plus 1, 28. So we've got 288. The LCM is 288. This is the smallest number that is divisible by 18, 24 and 32. So 288, when you divide it by 18, the remainder will be 0. When you divide it by 24, also the remainder will be 0. And by 32, the remainder will be 0. So this is the number least common multiple. Now what is the question? It says find the smallest 4-digit number. Now this is only a 3-digit number. So we have to find the smallest 4-digit number. The smallest 4-digit number is 1000. Okay, so you have to get a number like this, a 4-digit number which is divisible by 18, 24 and 32. Now we have got 288. What we need to do is write the multiples of 288 till we get a 4-digit number. Okay, so 1000 will not be divisible by these. So we're going to try and get a 4-digit multiple of 288. So let's write 288, say, into 3. 3 8s are 24, carry 2. 3 8s are 24, 25, 26, carry 2. 3 2s are 6, 7, 8. We've got 864, which is still a 3-digit number. So let's do 288 into 4. 4 8s are 32, carry 3. 4 8s are 32, 33, 34, 35, carry 3. 4 2s are 8, 9, 10, 11. So here we've got a 4-digit number. So 1152 is the answer that you get when you multiply by 4. The number before that, when you multiply by 3, is 864, which is a 3-digit number. Now, if you multiply by 5, you will get a 4-digit number, but bigger than this. So this is the smallest 4-digit number, which will be divisible by 18, 24, as well as by 32. So what is our answer? 1152. So the smallest 4-digit number, which is divisible by 18, 24 and 32, is 1152. This is our final answer. We will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.